Hello viewers, welcome to Tech Everyday. Please subscribe my channel and hit the bell icon to get the daily updates. So viewers, today we'll discuss about a problem like simple beam analysis. What we will see, we'll analyze the beam to see the shear force diagram and bending moment diagram. What we actually do in our civil engineering classes. So we'll compare the results. As you can see, there is a problem already solved. The bending moment diagram and the values, and also shear force diagram. We will also check the reactions uh, in ETABS. We will analyze this beam in ETABS and compare the results with our uh, uh, calculated uh, as per our formulas by structural mechanics. Okay, so to do this model, what some like 10 steps we need to follow. Like, first we will set up the grid lines. Second one is define the material properties. So we will assume the beam as a concrete rectangular beam, and the sections will be like 300 wide and 350 is depth, and the other properties like concrete compressive strength will be uh, 28 MPa, 28 MPa, which is actually 4000 psi, and Fy is 420 MPa, which is, if we US customary unit, if you can see, then it will be 60 ksi. Okay, so for river, we need this Fy is still yielding strength, and for concrete it is Fc prime and is 28 MPa. So this is actually the uh, like material properties for the concrete beam. And then we need to define section properties. Section is 300 and 350, and draw the beam. We'll just then draw the beam and assign the support. For point A it is hinge support, and then for point B it is roller support. And also we need to define actually the load patterns. So at first we'll since we are now a beginner, so we'll just discuss only two load patterns. Like, one is dead load, which is actually self weight. Another one is live load, and this is a live load, like, and the UDL and for point load. Okay, so two load pattern already been given as a default load pattern, so you can see later. Then we will assign the loads in our beam, and then check the model here if there is any error. Okay, and then run the analysis and check the results like SFD and BMD diagram and the reactions. So let's move on to the ETABS software. Okay, so we will open a new model. It is saved. So use built-in settings with. Okay, so we'll take like display units and metric SI, since we can see the in our problem that is like meter and kilonewton, so we need to take the units as SI. And concrete design code is CI31908. Okay, so now in X directions, how many grid lines do we need? So if you look at this beam, like for point A to B, and from point B, point A, B, and E. So for these points, actually, we need to draw a grid line. because A to B one is another one is like this grid line to define the supports, and for the cantilever part we need to draw another grid line here at point E. So we along the x directions we need to take three grid line, and for y directions we need to take only one grid line. So number of grid lines in x directions it is 3, and number of y directions it is 1. And custom grid spacing, so spacing of grid lines in x directions it is 8 meter. That means if we draw these three grid lines along x-axis in uniform spacing, that then we can use this spacing. Okay, otherwise we need to go to the custom grid spacing. So we are going with custom grid spacing because we have two different distances, like 5 plus 5 plus 2.5. That means 12.5 is one grid spacing, and another one is 2.5 meters. So we'll put it into custom grid spacing. So edit grid story data, edit grid data. Then you can see the this window like grid system data. So display grid data as ordinates. Ordinate means from x, from origin we need to provide the distance. Like if we go to our problem, then you can see if we consider that a point is the origin, a point is the origin, then from origin it is 12.5, and from from origin the point E it is 12.5 plus 2.5. That means uh, 14 15 meter. Okay, but if we uh, do not want this type of calculations, then we can change it like display grid data as spacing. Then we can just put it like from A to B it is 12.5 meter, and from B to C it is 2.5 meter. And yeah, that is done. And from for y grid data, only there is, since there is only one grid, so don't need any spacing. Okay, so then click on OK, and click on grid only, and click on OK. So actually we have already we did not actually modify the history data. So now let's move on to add and modify data, and modify show history data. So we don't need these stories, only we need story one, because we will just calculate a simple beam, so there is no story. So I'm selecting these three stories, and I'm deleting these stories, like delete existing structure at stories. Okay, we'll just keep one story. Okay. So now what we need to do, set up grid lines is okay, define material properties. Okay, so now move on to our materials. To define the material properties, go to the define and click on material properties, and then you can see there is the default properties like 4000 psi and a 615 grade 60. So 4000 psi, that means 28 MPa, what we are now doing. So it is okay for concrete. So just we change the name, because we are not giving importance in these material properties, because we just do a calculation for a beam for shear force and bending moment diagram. So don't need this one. We just give it to draw the sections. FC prime is 250, sorry, 28 MPa. uh, Click on OK. And for this one I'm changing it to fy, sorry, not 60, it is 420 MPa. Okay, I'm just changing the name. Now Material properties done. Now the next one is define section properties. So to define the section properties, uh, go to on define section. Okay, define, then section properties, that is then from section. So we don't need these sections. These are the default sections, so we'll use the customized sections. So to delete these properties, actually go to delete multiple properties, and then select all the type of sections, and then still delete selected frame sections, and then select one to here, sorry, select all the sections and delete frame sections. There will be one left because need the you cannot delete all the sections. Minimum one section is needed there, so that's why it's remaining. We'll delete it later. So we'll add a new property, and it is concrete rectangular. The section is concrete rectangular. The section you can customize the name like 300 divided by 350 beam size. I'm just giving one b1 name, and mm, you'll just need to change the section dimensions, like uh, it is 350 depth and wide is 300 and the material is 28 MB already. It is taken. So just go to on reinforcement and then change it to beam, because it is a beam, not a column. So design type is beam. Other things is like for longitudinal bars, that means river, already it has taken the strength of the reinforcement, so it is 420 MPa. All the things is keep the same because we don't need to change this anything here. So click on OK, click on OK, and you can now delete this property. Okay, and then click on OK. So section property is already been defined, and then draw the beam. Okay, now we need to draw the beam. So to draw the beam, you can go from here. Also you can go from the shortcut keys. So to draw the beam, like you can see here in draw section, so draw beam column brace. So we are now using the quick draw options, like quick draw beams. So like whenever I just click on the quick drawing, then there is a properties of object. You can see here there is a properties of object. So now select the property. Since there is only one properties, that's why it just already been taken, that p1. Okay, so then just click on this grid line, this one and this one. Just click on because we don't need to do anything, because just we have only one beam section, so we just click on two grid lines to draw the beam. Now exit this, and to see the beam properly, you can click on extruded view, then you can see that the beam already been drawn. Okay, so now we'll what needs to do next, draw the beam, assign the support. Okay, now we'll give the support at a point and at b point. At a point there is a hinge support, and at b point there is a roller support. So to assign the support, go to an assign and then joint restraint. So this is first one is fixed support, second one is hinge support, and third one is roller support, and fourth one is internal hinge. Okay, so we'll click on like hinge support and select on the joint, and then click on apply. So hinge support applied, and then click on roller, click on the joint, which joint actually will provide the roller support, then click on apply. So to see this one, just click on refresh view. Okay, just here there was refresh window. Okay, then you can see the fixed hinge support and roller support has been applied. Okay, now please close this section. So next one is define load pattern. Since there is the default load pattern as okay, so to define the load pattern, go to define and then click on load patterns. You can see there are two load patterns already been given. These are the like default load pattern. Okay, so we'll use this load pattern for UDL and point load. We will use the live load pattern, and self weight it will automatically calculate. Okay, so now load pattern has been defined, then assign the loads. Okay, so like there are two loads, one like this one is 1000 in this is a UDL, and this one is another UDL, and two is point load. Okay, so we will provide this to assign the loads. Go to the like assign, then frame loads, and then distributed load. So so from a point A to from point like first UDL, actually from A point it is going up to 5 meter. So define this like type of load pattern, we need to like first to select the live load pattern. Okay, and we'll provide it in trapezoidal loads, because if we put the in from load at the bottom in here, then uh, it will uh, it will automatically take whole of the span of the beam. Okay, uh, applied to whole of the span. Okay, so but we need only uh, first 5 meter the UDL. Okay, so that's why uh, we will provide it here from distance. So absolute distance from int I. So from distance 0 it is 1 kilonewton. So you need to be careful about the units. Okay, always check the units. It is kilonewton per meter, so we are giving it 1 because it is saying the 1000 newton per meter, that means 1 kilonewton per meter, 1 kilonewton. And from distance 0 it is 1, and 0 from distance 5, 0 to 5 it is also 1, because it is a UDL. So then click on the beam. I have already clicked. Okay, so then I click on apply. To see this one, actually you need to click on here. So sorry, you need to go to the elevations actually, because it is in plan section. So I'm going on elevation, then I can see that the load is 1 kilonewton per meter has been applied. Okay, so and from B to C, this beam actually there will be another load which is 1.6 kilonewton per meter. Okay, so we can we can like since so since the whole span in the live load is acting on whole span, so we can use this below options. Okay, so it is 1.6 kilonewton per meter, and the load pattern in name is live load, and then select on the beam and click on apply. Okay, the load pattern has been applied. Okay, now close in this section. Again, assign frame loads. Now it put on now will provide the point load. So for point load, the distance is first one is 5 meter and it is 8 kilonewton, and the second one is 7.5 meter, it is 4 kilonewton. Okay, so it will actually act on like from A to B span. Okay, So that's why we need to be careful about this one, because uh, okay, let's select on the absolute distance from end eye, and the first one is from point 5 meter, and it is 8 kilonewton. Then change the live load pattern name is live, and select on, like, in option section you can see the replace existing load. So since we did not apply any point load in that beam, that's why at first we will select this one, replace existing load. So it will not taking any it will not affect anything. So first one is replace existing load, and then click on apply. So 8 kilonewton already been applied. Another one, like 7.5 meter, and at the same beam. That's why, and load is 4 kilonewton. That's why we need to change the options, like add to existing load, because 8 kilonewton on that beam already been applied. And if we click on this options, replace existing load, then 8 kilonewton will be deleted. Okay, and then later the 4.4 kilonewton will be applied, because we are not changing the pattern name live load, and we are not changing the beam, but we are just adding the load. That's why you need to change it to add to existing load, like 7.5 meter from the point uh, a to that load. Okay, and load is 4 kilonewton, but then click on apply. You can see there the load already been added. Okay, now click on close this section. So load has already been applied, and you can assign the load has completed. Now check the model. So to check the model, if there is any error, then it will say automatically that there is a error. Okay, so to check this, and you go to the analyze section, and then you can find there a check section. Select deselect all, and then click on OK. So model has been checked, no warning message were generated. So now, to run the analysis, you need to save this model. I'm just giving it number like 2. So I've already saved. So now to run the analysis, you have to go to, you can go from here, run analysis. Also just click on this shortcut button. You can see there, run analysis. So uh, I'm running the analysis, already done. So to see the results, you need to go to display, and then force or stress diagram, and then support or spring reactions. First you see the reactions. Okay, for live load, we'll see the tabulated values. uh, okay, so abject directions. Okay, now click on apply. Now you can see the in at a point A it is showing abject is 10 kilonewton and abject is 11 kilonewton. So now you can see the results is, it has been already matched, 10 kilonewton and 11 kilonewton. Okay, so now we will need to look at the shear force diagram. So to see the shear force diagram, you need to go to display, force on stress diagram, and then frame PR spindle link forces. Okay, then shear force shear to 2, and then case is live load, and show values at controlling. Okay, just I'm giving this to see the values. Okay, now click on OK, apply, and I'm just increasing the scale to see it clearly. First one is -10. Oh, sorry. Actually, what happens, uh, compared to ETABS, we need to change it, like tension phase, moment diagrams on tension side, shear diagrams, animation sound. Okay, you can see here, 10, 7, it is 4. 10, 7, 4. But you can see here the results is showing opposite direction, in opposite directions. Okay. Uh, it is but if you go to the moment sections, okay, to see the moment diagrams, display, force and stress diagram, then frame or pair sections, and then moment, apply. Sorry, the value actually scaled. We'll just click at automatic. So what is actually happening here? So because moment diagrams on tension side, or ETABS actually taking the values for moment diagram where the tension actually grow. So at the bottom section, if we applied the load at uh, applied the load at top, then the tension will grow at bottom. So in the tension phase, it will show the moment. Okay, but in our theoretically, what we will do for positive moment, we are seeing here the upper side. For negative moment, we are locating it at the lower side. But uh, in ETFs, it will actually automatically take the positive means where the tension grow. Okay, so moment diagrams in ETFs always where the moment it shows, it will automatically show on tension phase. Okay, same thing is happening for shear. That's why it's just showing the opposite directions. Okay, but the value we can see it is already matched. That's it for the today. I'll discuss with another problem in the next day.
If you
Thank you.
like this video, please share this with others. Thanks for watching.